First, you're welcome to another episode of Data Analytics with Python Beginner's Guide. My name remains Vincent Hope. So today we are on Lesson 8. And what we're going to be dealing with today is descriptive statistics. So what is descriptive statistics? Now, this is usually the first step taken after cleaning and preparing a data set for analysis. It simply means we are trying to find the basic statistical data in terms of mean, median, and mode. So that's what we are trying to do when we talk about basic descriptive statistics. So let's jump right into it. Today we're going to load required libraries, that's the first step, and add the empty cars data sets. How do we add the empty cars data set? So you come to your inputs, you click add input here, you select your data sets, then you simply type empty cars. It's a data set. Now if you see empty cars, there are different types here, but we selected this one. You can see it has already been selected with this, it shows you in black. So we have added it already to the notebook here. So we're going to use it. So now if we look at the code, we put percentage matplot library inline, import numpy as p, import pandas as pd, import matplot library dot pyplot as plt. We're going to be using plt for the library. Then import os. Now the OS list directory, to see what is inside, we have kgul input empty cars, which has already been loaded. If you run this code now, you discover that under the empty cars, you have empty cars.csv. This is the CSV file that we're going to be working with. So let's make progress. We move on to the next one. Now we see that here, let's scroll up a bit so that we can see what we're doing. Okay, let's scroll up a bit. Now, so what did we do now? We said the empty cars, we pass it on to empty cars CSV. Under the empty cars input cargo, we pass it on to empty cars again using the pd read CSV into this file. Then we now say empty cars.head to display and see the kind of data that we have there. Now this is the serial number, we have the model, we have the miles per gallon, we have the cylinder type, disposable, HP, DRT, and the rest data here, gear and the rest of it. So this is what we have here. Now the next thing we want to do before we begin to work on these data sets is we want to delete the serial number column. The serial number column is showing you right here. Let me scroll up a bit, okay. So this is the serial number column, so we don't need it for our statistical analysis. So how do we achieve that? We say empty cars equals to rename the column, which is an unnamed column. There is no name. This unnamed column 0, rename it to model, although you still have a model, but there's something we want to do there. Then empty cars.index equals to empty cars model. Now that's make it an in index format equals to this model, pass it as an into index format. Then you delete that empty cars model column, which is the new column that was just created. By the time we run the code again, if we run this code, we discover that this serial number here has been eliminated. So we just have this and the remaining data intact. So let's make progress. Okay. Now, how do we determine it now? To determine the mean, which is the first basic statistical descriptive statistics, we simply say the name, we passed it on to empty cars dot mean, and you put the dot mean, the main function. So when you put the main function, and if you run the code, you see that it takes the mean for each column. This is miles per gallon, this is the cylinder, this is the disposable HPS, DCAT, and the rest. Now so the empty cars means it takes the miles per gallon mean is this, the cylinder this, display this. So each column, it gives you the mean for each of the columns on the data sets, depending on the data set that you have. Now, let's make progress. Now we'll make progress. Now, if we make progress, let me scroll down a bit. Okay, now to determine the row mean, what we have determined so far is the column mean, which is all the data set from here, 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 and here. Now we want to determine the data set, the column mean like across like this. That's according to the rows. So it's the same code, but with a different alteration. So here now it's still the same empty cast dot mean. Now this is now axis equals to 1. The former axis was empty, so Python took it as axis 0, which is the column. But now axis is into 1 means that it's the row column. The rows is going to take. So you can see that now the output, it gives you Mazda 29 points this for Mazda 40.wag 29 points this, Datsun this, and it gives you like that. So this is how you find the mean per row. Now we make progress. So if we make progress, now we want to get the median. It's almost the same, so but it's the same. The function is empty cast dot median, the median function. When you run this, if you run this, it gives you the median. If you want to get for the median for the rows, we can change this, do the same thing here. We can say axis equal to 1, and we run the code. It will give us the median for each of the different cars in the row format. So let's make progress. Let's make progress. Okay, now let's see the number of rows and columns we actually have on this data set. So we use the emptycast.shape. Then we discover that we have 32 rows and 11 columns. 32 rows and 11 columns. Now we can now determine the mode, that which is the highest occurring number in each of the columns. If we run it, you discover that you have just 6 records here, 7 records, 0 to 6, which is 7 records for each. So these are the mode for each of the columns. Each of the columns, these are the mode. Now let's change it through let's do it by the rows. So say axis equal to 1. We run the mode there and let's see what it gives us. Now we say Mazda, okay, Mazda 4.0. So this in terms of the mode on the rows, these are the highest occurring values. So that's how we deal with the mode. Now let's make progress. Okay. Now if we come down here, now we have just finished the basics of mean, median, mode. Now let's look at measures of spread. Measures of spread. Now, what are the measures of spread? This describes how a set of observed variables are similar or varied from a particular variable or data item. How a set of observed variables are similar or varied from a particular variable or data item. Now, measures of spread include the range, quartile, interquartile range, variance, and standard deviation. So how do we achieve that using Python on a data set? So let's make progress. Now, to determine the range is simply the difference between the highest value and the lowest value. So we take the max for a particular comma, max empty cast miles per gallon. We are using miles per gallon here, minus minimum empty cast miles per gallon, the same column. And when you run the code, you get 23.5. This is the range for miles per gallon. You can change the column name here depending on the columns you want to use to get your range. Now, to determine the percentile, this is a summary of the several percentiles used to determine the variable spread. We have 0 percentile. Usually we start with 25 percentile, 50th percentile, 75 percentile, then the full whole. So if we want to get for the percentile for each of a particular column. We say percentile. This is just a name created, which you can use any name. Percentile numbers equals to empty cars miles per gallon dot quartile 0. That's the base level. Empty cars miles per gallon quantile 25%. This represents 50%, 75% whole. Then you run to get out the output. So you discover that 10.4 is at its base level, 15.425 is the 25th percentile, 19.2 is the 50th percentile, and so on and so forth. Now let's make progress. Okay, now we want to see how we can get this in a summary. Instead of doing it one by one, how do we generate all? We run the code emptycars.mpg miles per gallon .describe. If you run that code there, it will give you the count of the data. It will give you the mean of that column. It will give you the standard deviation. It will give you the minimum. It will give you 25% percentile, which is 25% is 15.4 here. What did it give us here? You can see the same thing here, 15.425. Yes, we have the 50th percentile, 19.2. They gave us 19.2 here. You also have 75% here, 22.8. You see it here. The same thing with the max, which is at 3.9. So this is how it generates the summary of all the descriptive statistics, which is mean, median, and the rest of it. Now the mean, minimum, maximum, and the rest of it. Now let's make progress. Now if we want to determine the interquartile range, now we said interquartile range is empty cars mpg dot quantile, which is the 75% minus the same code or the 25%. So the interquartile range is the difference between the 75% and the 25%. When you run this code now, you have 7.375. So this is the interquartile range, and this is how you determine it. Now let's make progress. Okay, let's make progress. So now to visualize the values using a plot, we use a normal plot. We use a box plot here. So empty cars.box plot. The column is miles per gallon. We want to see the miles per gallon in relation to the axis. So the miles per gallon, okay, we want to see it in relation to the return type, the axis. The figure size 8.8. Now we want to plot some text so that we can understand how it relates or how it can be described. So we say plot plt.text, x is equals to 0.74 and y is equals to this. The text we're going to put there is the third quarter. What are we simply saying? That this third quarter should be positioned exactly at these 2 points, x here, y, x. For the median, x and y. For the first quarter, 0.75, 15. So by the time you plot this now, using a box plot format, you discover that this is what you have here. This is your box plot. This is the minimum value. This is the first quarter. This is the median. This is the third quarter. This is the max. So all this information is being plotted using the code that you see here. So you can replicate that in your practice. So now let's make progress. Okay. Now we have to determine the variance value. Okay, it's an error here. The variance value. Remove this. Variance value of this is the value of the squared difference from the mean. Okay, variance is the value of the squared difference from the mean. So you say emptycars.mpg.variance. So this is the code for variance. When you run the code now, this is the variance. This is the output. So it's simply the data set dot the column you want to find the variance dot vr column. Then finally, you want to get to determine the standard deviation, which is the square root of the variance. You simply say emptycars.mpg.standard deviation. When you run that code, you generate 6.02 to this, which is the square root of 36. So you can see that this is how we do basic descriptive statistics with Python on a data set. Hope you have understood what we have done. So if you have any questions or observations or things you want us to treat, please feel free to drop your comments. My name remains Vincent Hope. Thank you for watching.